Institute of Aeronautical Engineering, Electrical and Electronics Engineering. Tech Talk AAT-1. Name N. Venkat Sai. Roll number 23951802226. Branch Electrical and Electronics Engineering. Subject Microprocessor and Microcontroller. Topic Hierarchical Temporal Memory on the Automata Processor. Hierarchical Temporal Memory on the Automata Processor. This presentation offers an in-depth look into hierarchical temporal memory, a cutting-edge brain-inspired machine intelligence paradigm. We will satisfyingly focus on its groundbreaking implementation using the specialized automata processor hardware. Join us as we explore how this century unlocks unprecedented performance for real-time unsupervised learning in streaming data, presented in August 2025. This overview highlights the convergence of neuroscience-inspired algorithms with highly parallel computing architectures to address some of the most challenging problems in artificial intelligence. What is hierarchical temporal memory? Hierarchical temporal memory is a biologically constrained artificial intelligence model that draws profound inspiration from the human neocortex, the seat of higher cognitive functions, developed by Numitna, including and rooted in the pioneering research of co-founder Jeff Hawkins. Hierarchical temporal memory represents a significant departure from traditional neural networks. Unlike many AI models that requires vast labeled datasets, hierarchical temporal memory excels at learning time-based patterns in continuous streaming data in the entirely unsupervised manner. This inherent ability to understand the temporal dimensions of data makes it uniquely suited for a range of crucial applications, including real-time anomaly detections, accurate future predictions, and robust classifications tasked in dynamic environmental. Its brain-inspired architectures allow it to continuously learn and adapt much like a human brain, making it particularly powerful for scenario where data patterns evolve over time. Biologically inspired mimics neocortical principles for robust continuous learning without supervision. Unsupervised adaptation learns from data streams without explicit labels of human interventions. Temporal pattern learning specifies and identify and predicting schemes streaming data. Key applications primarily used for anomaly detections, predictive analytic, and dynamic classifications. Biological inspiration behind hierarchical temporal memory. The architectural foundation of hierarchical temporal memory is deeply rooted in the intricate structures and foundation of the mammalian neocortex, especially hierarchical temporal memory models in the behavior of pyramidal neurons and the organization of control columns, which is able to the fundamental computational units of the brain. These models are designed to mimic the brain's remarkable capacity of hierarchical, temporal, and spatial pattern learning. At the core, hierarchical temporal memory embodies the thousand brains theory of intelligence, a concept proposed by Jeff Hawkins that suggests the neocortex operates not as a single, monolithic processing unit, but as a collection of thousands of independent yet interacting models distributed across the cortical surface. Each of these midbrains of cortical columns learn complete models of the object and their behavior through sensor input. Within a hierarchical temporal memory system, individual hierarchical temporal regions or nodes are enabled to learn both spectral patterns and temporal sequence. This dual learning capable allows hierarchical temporal to build a rich dynamic representation on its own, much like the brain continuously constructs and updated its internal models of the world through sensor experience of the motor interaction. These hierarchical arguments of this region future enables the system to abstract the simple features to complex concepts, honoring brain's ability to process information and multiple levels of gradation. Core concept of hierarchical temporal memory. Hierarchical temporal memory relies on the few fundamental biological inspired mechanisms to process and understanding streaming data. This core concept from the backbone of its unique learning capabilities. Spectral pooler. The spectral pooler is the initial stage of hierarchical temporal memory. Its primary role to the conventional ability to data. Wherever it is sensor to the readings text or images into the spectral dictionary columns and cells. Within both of the spiritual pool and temporary memory, the fundamental units are columns and cells. A column represents a group of neurons of the respond to similar inputs features akin to the cortical column in the brain. Temporal memory. Building upon the SDRs generated by the spiritual polar, the temporal memory component is responsible to learning sequence of these structural patterns. Continuous unsupervised learning. A hallmark of hierarchical temporal memory is its ability to learn the continuously and unsupervised. It does not require labeled data and background, adapting the real-time involving data streaming. Hierarchical and temporal learning in hierarchical temporal memory. The power of hierarchical temporal memory lies in the ability to process information across multiple levels of abstraction and to deeply understand the temporal relationships within data. Hierarchical organization. Hierarchical temporal memory systems are typically organized as the T-shaped hierarchy of connected region and nodes. Each region processes different aspects of level abstraction of the incoming data. Multi-order sequence prediction. Unlike many traditional AI models of the struggle within the long-range dependencies, hierarchical temporal memory and hierarchical structure enables multi-order sequence prediction. Temporal pooling. A crucial mechanism within hierarchical temporal memory is temporal pooling. This process allows the system to the group sequences inputs into stable, higher level representation for causes. For example, a sequence of individual visual frames might be pooled into the concept of walking person. Continuous interference. Hierarchical temporal memory perform continuous interference, constantly referring it is instructional model as new data streaming. This dynamic learning process ensures the system remains adapting the robust and changing patterns in the environment without the need of periodic retaining. Challenges in hierarchical temporal memory computation. While hierarchical temporal memory offers compelling advantages through the biologically inspired learning mechanisms in computationally intensity presents significant challenge, particularly real-time high throughput applications. Sequence memory. The core of hierarchical temporal memory, temporal learning in the sequence memory realizes the high complex and dynamically programmable interconnects between its cells and columns. The intricate connectivity essential of learning and prediction sequence process of diffusion bottom of traditional CPU based and in the CPU based implementations. Multi-order interference expense. Hierarchical temporal memory it able to perform the multi-order sequence prediction under standing patterns across the longer time horizons. It is a power feature but comes with a higher computational cost. This can hinder hierarchical temporal memory deployment in the low latency environment. Need for hardware acceleration. To truly unlock hierarchical temporal memory potential for real-time applications such as the high-frequency random detection inertial autonomous systems are finding trading specialized the hardware acceleration crucial. Dedicated hardware can be overcome the limitations by providing the necessary parallelism, memory bandwidth, and low tendency processing the hierarchical temporal memory. Interference able to demanding sensors. Introduction to the autonomous processors. The autonomous processor to revolutionary and non-numeric computational architecture specially designed at the hexagonal tech involved massive parallelism and pattern matching in the state mechanism developed by the microtechnology to represent discrete depths from traditional CPU and GPU designs, which is the optimizing for arithmetic operations rather than complex patterns recognizing the large database. By processing the directive hardware supporting for the state mechanism execution, the autonomous process offers the unique solution to the computational challenges faced by algorithms like hierarchical temporal memory, promising significant outputs of the dynamic pattern recognized in the temporal data analysis. Mapping hierarchical temporal memory to the automotive processor. The inherent parallelism and pattern matching capabilities of the automotive processor make to the executional well suitable architecture for the computing hierarchical temporal memory designs to overcome the computational bottlenecks. Sequence memory, auto reflex memory. Recent advantages and performance gains. The integration of the hierarchical temporal memory with the autonomous process has led to significant breakthroughs in performance, transforming hierarchical temporal memory from the computationally intensive algorithm into a high efficient solution for real time applications. Conclusion and future outlook. The journey of hierarchical temporal memory for the biologically inspired theory to a highly efficient hardware accelerated system marks a significant milestone in the field of the mission intelligence. Hierarchical temporal memory core value. Hierarchical temporal memory continues to stand out as a unique and powerful framework for sequence learning, offering a fundamentally different approach compared to deep learning with the initial biological grounding, unsupervised learning, and continuously adapting. Its ability to learn from streaming data without labels to make it invisible for novel and unpredictable environment. Autonomous processor impact. The integration with the autonomous processor has been a game changer, significantly boosting hierarchical temporal memory's interference with speed and addressing it primarily computational challenges. This century has moved of hierarchical temporal memory from the theoretical curiosity to the practical solution for real-time application, proving the potential of specialized hardware for neuro algorithm. Look ahead, the potential applications and research direction are the wish. Border adoption. With the acceleration performance, HMT is the poised for border adoption in crucial areas such as the industrial anomaly, direct cybersecurity, their analysis for fraud detection, and complex sensors AI for the robotic autonomous vehicles. It's a real-time capability and crucial in the dynamic fields, enhanced multi-order interference. Ongoing research will focus on the future enhancing hierarchical temporal memory's multi-order interference capabilities on specialized hardware. This involves optimizing the representation and processing of longer, more abstract sequence, enabling more super satisfied predictive modeling and cause interference, scalability, and edge deployment. Future work will also target improving the scalability of HTM for even large data sets and more complex environments, and while the refraining the deployment on ultra low power edge devices, bringing adaptive intelligence across our data source. Thank you.